Okay, we have the formula for the amount in the account after time t. You initially deposit $2,000, and then it's compounded continuously at a rate of 2.5%. And so the first question, A, is just a calculation question. When t is 80 years down the line, how much money is in the account? And so we have to, without a calculator, it's going to be tough, but we have to plug in an 80. Okay. So let's see what the best way to do that. This 0.025, let's convert that to a fraction. 0.025, what is that? As a fraction, it is 25 over 1,000. So that it is, yeah, 25 over 1,000. Is that 1 over 40? I think, yeah, that's 1 over 40. 25 goes into 104 times. It goes to 1,040 times. Having it as 1 over 40 is helpful because we have to take that and multiply it by 80. So we have e to the 1 over 40, and we times that by 80. So we're talking about e squared. Okay, that's a of 80. Take 2,000 and multiply it by e squared. Just to give us a feel for what the number is, let's go to the calculator. And we have 2,000 e squared. $14,778.11. So your 2,000 basically multiplies by 7 into 14,000. And it takes 80 years to do that, though. Anyway, great. Now, part B. The instantaneous rate of growth. Fancy way of saying the derivative. So they want, this is A. Over here, let's do B. They want A prime of t. So we take the derivative. 2,000 is a constant, it stays there. The derivative of e to anything is e to that exact same thing. Chain rule though, multiply by the derivative of that exponent. Anything times t is just that constant, so 0.025. And let's simplify that. We have this 2,000, and once again this is e to the 1 over 40 times t. Let's call it t over 40. And then this is once again 1 over 40, and that 40 can turn this 2,000 into 50. No, 500. 50. So 50 e to the t over 40 is the derivative. That's a prime of t. They are specifically asking for when it's 40, when t is 40. So they want a prime of 40, so that's 50 e, because it's 40 over 40, which is just 1. So 50 times e would be the instantaneous rate of growth at 40 years. Let's go to calculator again to get that. E is about 2.7, so 135.91. The units will be dollars per year. $135.91 per year. After 40 years, that's about how much it's growing each year. And then finally, part C, the equation of the tangent line. So we have the derivative at any time t is 50e to the t over 40. Plug in now t equals 20. So that's 50e to the half, because 20 over 40 is a half. 50 times the square root of e. That's the slope of the tangent line. Okay. They want the equation of the tangent line. We need the slope, but we also need the x and y coordinates. So the t and a coordinates. T is 20. We need a, which is a of 20 is 2000 e to the half, because 20 over e to the half. So a is 2000 root e. T is 20. T is like x. That's your input variable, your independent variable. A is 2000 root e. That's like y. And then we have the slope. So let's do it as y equals mx plus b, or a equals mt plus b. 2000 root e is 50 root e times 20 plus the b. 50 root e times 20 is 1000 root e. And if we have 2000 root e, subtract that over, it leaves us with 1000 root e for b. Okay, so we have the b, we have the m. We put these two guys together. A is equal to m t plus b. So it looks a little strange, but yeah, that's the answer to that one. So we have, this is the answer to C. Great. And this is the answer to B, dollars per year. This is the answer to A, which amounts to about $14,000.